Okay, now I'm going to present what we have done for our group project, which is for group 1. Okay, this is for introduction. Oops. Okay, uh, for the circuits, we have to uh, solve uh, the task, which is two tasks we got uh, for the calculation and simulation. Okay, but for the calculation, we need to use three methods, which are nodal analysis, mesh analysis, and superposition theorem. So I will tell about the methods we have used for solve the calculation. So nodal analysis states that the sum of voltages around a circuit is zero. Several interconnected loops form a mesh. In this way, is able to write a system of equations that can be solved for voltages and currents in the connection. So node analysis and mesh analysis are closely related. Similarly, mesh analysis states that the sum of currents entering or leaving a node is zero. This allows you to write another system of equations that can be solved for all currents and voltages in the circuit, which are a collection of interconnected nodes. So mesh analysis and node analysis are closely related. Superposition theorem as a circuit analysis tool takes advantage of the linear nature of the circuits, allowing specific current and voltages to be solved for by deactivating all but one independent source at a time, and then add the result together. A mesh or node analysis can be used for individual solutions. Okay, for task 1, which is calculation, we are using nodal analysis for our step. So from nodal analysis, we must apply KVL to find voltage at V1 and V2 nodes. So here's shows that the current flows in clockwise direction. So this is equation from for node V1 and node V2, and simplify the equation and using elimination methods and get V1 equal to uh, 5.702 volt and V2 equal to 9.447 volt. Okay, next we proceed with mesh analysis. So mesh analysis, we must apply KCL, Kirchhoff current law, to get uh, currents at each loops. So here is at loops 1 already have the currents, which is 2 ampere, and loop 3 already have the current 4 ampere, and just simplify the equation and solve with matrix methods, and this is the calculations. And I1 still same with 2 amperes. I2 we got negative 40 over 47 ampere, or negative 851.064 milliampere. Sorry for my careless. I3 equal to 4 ampere, I4 equal to 4 over 47 ampere, or 85.106 milliampere. Sorry for my careless too. So we proceed for superposition theorem. So for first step, we just open circuits for the current sources at loops 1 and loops 3 again, and then got the B1 prime equal to negative 32 over 47 volt, because we read from the potential, lower potential to positive potential here. And V2 we got 48 over 47 volt. And uh, next step, we just short circuit the voltage source and uh, uh, open circuit the current source at I3 and got uh, this voltage values. And this also we just short circuit the current the voltage source and open circuit the current sources at loop 1. So we got this value and the final result is V1 is sums of this V1 primes. We got 5.702 volt and V2 we got 9.447 volt. Uh, and these both voltage values are same to nodal analysis value and simulation values. So next step, superposition theorem is just to find the currents at each loops. So our first step is open circuit the current sources, dispose current sources, and consider the loops are not exist. And just simplify the equation and uh, uh, solve with matrix methods and get these values. And then next step, just short circuit the voltage source and open circuit the current source at loop 3, which is 4 ampere, and simplify the equation and solve the solve using matrix methods to get these values. And same, just short circuit the voltage source and open circuit for current source at loop 1, which is 2 ampere, and simplify the equation and solve with matrix methods and get these values. And the final results is uh, I1 equal to 2 amperes, same to the current source. I2 equal to negative 40 over 47 ampere. Uh, I3 equal to 4 ampere, as we see here. And I4 equal to 4 over 47 amperes. So these values also same uh, with values by using mesh analysis and uh, simulation values. So that's all for the calculation from me. Thank you.
I am going to explain about simulation part to find the value of current and voltage. For nodal analysis, we are going to find the voltage of VA and VB. The first thing we need to do is to find all the components, as I already find all of this here. And then we have to connect all the components into one circuit. So you just have to connect all of the components like this. After we complete the circuit, we have to take probe voltage and put at VA and VB to find the voltage. So we put it here and here because this is VA and this is VB. So and after we put the probe voltage, we are going to run the program. And it will show us the value of VA, which is 5.70 volt, and VB is 9.45 volt. Okay, that's all for nodal analysis. I am going to explain about simulation part to find the value of current and voltage. For nodal analysis, we are going to find the voltage of VA and VB. The first thing we need to do is to find all the components, as I already find all of this here. And then we have to connect all the components into one circuit. So You just have to connect all of the components like this. After we complete the circuit, we have to take probe voltage and put at VA and VB to find the voltage. So we put it here and here because this is VA and this is VB. So and after we put the probe voltage, we are going to run the program. And it will show us the value of VA, which is 5.70 volt, and VB is 9.45 volt. Okay, that's all for nodal analysis. Next is mesh analysis method. We are going to follow the same step as nodal analysis to design the circuit, which is firstly we have to find all the component that we need, and then we need to connect all the component in one circuit. Right? And lastly, we are going to put the ground here. Okay. Okay. After we put the ground, we have to take a current probe and put the current probe at loop 1, loop 2, loop 3, and loop 4. So I'm going to put it here in reverse probe. And then after we put all the probe, we have to run the program. Then we have to run the program, and it will show us the value, which is for loop 1 we have 2 ampere, and for loop 2 is negative 851 milliampere, for loop 3 is negative 4 ampere, and for loop number 4 is 85.1 milliampere. So that's all for mesh analysis method. For superposition theorem, the circuit is quite different because we have 3 independent sources. Therefore, we need to design 3 circuits because only one independent source can turn on at one time. The first circuit we are going to turn on is I1, so V1 will be short circuit and I2 will be open circuit. As you can see from this circuit, I already find all the components. The next step is we have to connect all the components together. So after we finish connect all the components together, we have to take probe voltage and put at the node VA and VB. And then after we put the probe voltage for VA and VB, we are going to run the program. And it will show us the result of VA and VB. So for the first circuit, the value of VA is 2.81 volt and for VB is 1.79 volt. The next circuit is we are going to turn on V1 and I1 and I2 will be open circuit. So firstly, we have to connect all the components together. After we connect all the components together, we are going to put probe voltage to calculate the voltage of VA and VB for this circuit. So after that, we have to run the program to get the value of VA and VB. So the value of VA for this circuit is negative 681 millivolt and for the VB is 1.02 volt. For the next circuit, we are going to turn on I2. For V1 is going to be short circuit and I1 is going to be open circuit. So I already have all the component and we have to connect the component. After we finish connect all the circuit, we are going to put a probe VA and VB to find the value for this circuit. So we have to run the program. As you can see, from VA we got 3.57 volt and for VB we got 6.64 volt. So this is the value for VA and VB for this circuit. After we get all the value of VA, we are going to add all the value, which is negative 681 millivolt plus 1.81 volt plus 3.57 volt. So after we add up all the value, we are going to get 5.70. For VB, we have to add up 1.02 volt plus 1.79 volt plus 6.64 volt and we are going to get 9.45 volt. So the result is same as nodal analysis for both voltage, which is VA and VB. For this circuit, we are going to find the value of current. So as you can see, for this circuit, we are going to turn on the V1. So I1 and I2 will be open circuit. So the first thing is we need to connect all the component together. After we finish connect all the component, we have to take the probe current and put it at the place that we want to find the current. So we are going to find the current for loop 2 and loop 4. So we put it here and here. So after we put the probe current, we have to run the program. And as you can see, for loop number 2, we get 340 milliampere, and for loop number 4, we get 766 milliampere. So this is the value of loop number 2 and number 4 for this circuit. So after we finish, uh, so after we finish complete all the circuit, we are going to find the current for each loop. So in this circuit, we have 3 loop, which is loop number 1, loop number 2, and loop number 4. As you can see, um, the original circuit, we have other loop here, but in here we have a current. So if current, it will going to be open circuit, so there's no current flowing here. So because of that, we only have 3 loop. So we have to take the probe current. After we finish put all the probe current, we have to run the program. And as you can see, for loop number 1, we get 2 ampere. And for loop number 2, we got 596 milliampere. And for loop number 4 is 340 milliampere. So this is the value for loop 1, 2, and 4 for this circuit. So for the next circuit, we are going to turn on I2, and V1 will be short circuit and I1 will be open circuit. So we have to connect all the components. Okay, after we finish complete the circuit, we are going to put probe current for loop number 2, loop number 3, and loop number 4. After we finish put all the probe current, we have to run the program. And as you can see, for loop number 2, we get negative 1.79 ampere. And for loop number 3, we got negative 4 ampere. For loop number 4, we got negative 1.02 ampere. So this is the value of loop number 2, loop number 3, and loop number 4 for this current. After we get all the value of each current, we are going to add all the current to get the total for I2, I4, I1, and I3. So for I2, we are going to add 340 milliampere plus 596 milliampere minus 1.79 ampere. So we are going to get negative 0.85 ampere for loop number 2. So for loop number 4, we are going to get 766 milliampere plus 340 milliampere, negative 1.02 ampere. So the total for I4 is 0.085 ampere. I1 is 2 ampere. So for I3, we get negative 4 ampere. So the value for all of the current is same as mesh analysis. The discussion for this report is that the calculation are the same result in simulation. For this experiment, we discovered that nodal analysis is using an application of Kirchhoff current law, which is used for calculating the voltage at each node in an equation. Therefore, we need to analyze the circuit with 2 nodes, which is VA and VB. Meanwhile, mesh analysis is an application of Kirchhoff voltage law, which is used for calculating the current. And this is done by identifying all the loop in the circuit, which is loop 1, loop 2, loop 3, and loop 4. For superposition theorem, we need to switch on only one independent source to find the voltage and current in each resistor. Therefore, independent voltage source will be short circuit and independent current source will be open circuit. For example, when we turn on I1, V1 will be short circuit and I2 will be open circuit. And it going to be the same for other circuit. For conclusion, in this experiment, we are able to solve the value of current and voltage using variety of methods such as nodal analysis, mesh analysis, superposition theorem, and others. Other than that, we can also familiarize ourselves with component and symbol from the multisim to design the circuit. And then we also can learn how to find the value of current and voltage by using multisim and check whether the value of the calculation is same as simulation. So that's all from me. Thank you.